Have you ever looked at a massive concrete bridge, or maybe a skyscraper that just seems to pierce the clouds, and wondered what really keeps it standing? Year after year, through all kinds of weather? Well, the secret isn't just about its size. It's actually a tiny, almost invisible detail that acts as its most important shield. So today, let's dive into the hidden world of concrete and find this unsung hero.
So, let me just ask you this straight up. What do you think is the single most important yet almost always invisible part of any concrete structure? It's not the strength of the concrete mix itself or even the steel that's buried deep inside. Nope, it's something much, much simpler. It's a single detail that decides whether a structure lasts for its full design life or if it starts to crumble way too soon.
And here it is. The answer is concrete cover. The easiest way to think about it is like armor. See, inside pretty much all concrete, there's a skeleton of steel bars. We call it rebar, and that's what gives it its tensile strength. The concrete cover is that very specific measured layer of concrete between that steel skeleton and the outside world. It's a shield, plain and simple.
And it absolutely has to be a good shield because it is the #1 line of defense against the biggest enemy of reinforced concrete everywhere. And this isn't some brute force attack we're talking about, it's a quiet, creeping danger that can bring down even the mightiest structures, from the inside out.
And that threat? It's corrosion. We all know it as rust, right? But in the world of structural engineering, corrosion is this incredibly destructive process. It wages a silent war on all that steel reinforcement that's supposed to be hidden safely inside the concrete. And it all kicks off the moment that protective shield, the concrete cover, isn't up to the job.
The whole process is deceptively simple, and honestly, that's what makes it so dangerous. First, if the cover is too thin, moisture and air and other chemicals can seep through and reach the steel. Second, that steel starts to rust. But here's the real kicker, the crucial step. As steel rusts, it expands. It can actually swell up to several times its original size, and that creates this immense internal pressure that literally cracks the concrete from the inside.
So this is way more than just a cosmetic problem, a few rusty stains on a wall. It's summed up perfectly by this statement: corrosion reduces structural capacity. What that really means is the structure's ability to safely carry the loads it was designed for, to just do its job, is getting weaker and weaker. The steel skeleton is being eaten away while the concrete armor is being cracked and broken by that expansion.
And right here, you can see exactly what that means in the real world. On the left, that's the structure's original strength, just as the engineers designed it. But on the right, look at that dramatic drop after corrosion gets a foothold. That gap? That represents a loss of safety, a much shorter lifespan, and basically a ticking clock towards potential failure.
Okay, so if this is so obviously dangerous, why in the world does it happen? Where is the point of failure? Now, you might think it's a problem with the materials themselves, but the truth is actually a lot more straightforward. And it happens long before the building is even finished. The failure isn't in the concrete or the steel. The weakness gets introduced during the construction itself. It's a breakdown in execution, in site control. It's human error.
Let's just compare the two paths here, side by side. On the left, with the correct cover, the steel is safely sealed away, totally protected. The structure is durable, it's going to perform exactly as designed for decades. But then, look at the column on the right. With insufficient cover, that whole chain reaction starts. The steel is exposed, corrosion starts early, and the structure's strength and lifespan are compromised from the get-go.
So what causes this? Well, a lot of the time, it's something as simple as these things called spacers. They're just little supports that hold the steel cage in the exact right spot while the concrete is being poured. But if they're the wrong size, or they're misplaced, or they're just missing, that steel can shift. You combine that with a lack of really diligent site inspection, and that protective shield is broken before it's even fully formed.
The good news in all of this is that a process failure has a process solution. We don't need some miracle new material, we just need to engineer for durability right from the very start. It really all comes down to getting the process right on site.
The solution is as elegant and simple as the problem itself. It boils down to this: correct cover improves durability. That's it. That's the fundamental rule for building things that are meant to last.
In getting there, it just comes down to being diligent. It means engineers specifying the right spacers and contractors actually using them correctly. It means having really tough site control and supervision. And maybe most importantly, it means doing thorough inspections to check that the rebar and the cover are perfect before a single concrete truck shows up. Because once that concrete is poured, it's too late.
You know, when you zoom out, this small technical detail is really about something much, much bigger. It's about the legacy we're all building in concrete and steel. It's about making sure that the infrastructure we rely on every single day isn't just built, but that it's built to truly last.
And that brings us to the core takeaway from all of this. Durability is never an accident. It's the result of thousands of conscious, deliberate decisions made by engineers and builders. It's literally engineered into the design. One correct spacer, one diligent inspection, and one crucial millimeter of concrete cover at a time.
So the next time you cross a bridge or walk into a skyscraper, think about that unseen shield of concrete that's protecting its steel heart. And then ask yourself, knowing that the solution is this simple, are we paying enough attention to the little details that ensure the infrastructure we build today is truly, genuinely designed to last?